Hello everyone and welcome to this session, and in today's class I am bringing the physics concept of class 10th grade. And what we are going to see today, this was discussed in the last class poll, and according to the poll today we have to do understanding lenses. So yeah, in the poll students have required that they want to know the lenses, right? So in that continuation of that I am going to take lenses for you now, and this is a grade 10 physics topic of chapter light. Now without wasting time, let us get into the lenses part. First we should understand what is lenses. Lenses are nothing but it is an optical instrument. Basically it is a piece of glass with a very different shape. You must have seen glass around you which is having different types of shape, but lens are also made up of glass, but there is a different way of making them. So let us try to understand how these lenses are basically made. So first let us understand these lenses and how they are basically made first. Alright, so they are made up of glasses. As I told you, they are made up of glasses. Okay, the material that is used for make lens is glasses, and you can create the glass in these two ways. Either you can make the glass like this. How are you going to make this glass like this? You take a half portion of plano convex sides. Can you see? You have two plano convex lenses. These are called two plano convex lenses. Now when you attach these two plano convex lenses, so you are having two plano convex lenses. So the name of this type of lens is plano convex lens, because one side plane, one side it is convex. Can you see? One side it is bulge and one side it is completely straight. So these are plano convex lens. So if I take two plano convex lens and attach them, I get a convex lens. This is known as the convex lens, and of course it is made up of glass. And you see how it is made up of glass, but it has a thick shape at the center, and on top it is kind of thin. So it is thick at the center and top it is thin. So this is the special feature of a convex lens. This is a special feature of a convex lens. In the same way, I have another lens where I am taking two, what it would be, plano concave surfaces. Okay, I am taking two plano concave surfaces. As you can see here, two plano concave surfaces I am taking. So these both surfaces are called plano concave, and again they are made up of glass, right? So when I join them together, I am going to have a concave lens. As you can see, I am going to have my concave lens here. This is known as concave lens. Okay, concave lens. And if you see the concave lens, they have thin center. At the center they are thin, and at the top they are actually thick. So the geometry is just opposite to convex. Okay, in convex you see the center part is thin and the top part is, center part is thick and the top part is thin, whereas in the concave lens you would be seeing that the center part is thin and the top part is thick. So this is the basic geometry of any lens. Okay, now we understood what lenses are and what they are made up of. Now let us try to understand what are the parts of lenses. Okay, let's understand what are the parts of lenses and what are the points which are required for ray formation. Okay, you know that lenses are used for magnification, and lenses not only do magnification, but lenses can do a lot of other things. And if you have to understand what are those lot of other things, I'm sure that you have to understand the image formation, right? And for image formation you have to know certain rules, and those are the rules that we are going to see now. Let us try to understand some rules that are very much required for lenses. So let's go to the new page and let's try to understand a few things. I will do with the convex lens, because convex lens is little more easier to understand. So I will begin with convex lens, and this is my convex lens. I am going to make a bigger version of convex lens, and it is little thin version of a convex lens. Okay, now every convex lens, every lens, I am not saying convex lens, every lens will have an optical center. So basically this optical center is a geometrical center of the whole lens. Okay, if you see this lens, this is the side view of the lens. If you look at the front view, it will be circular. The front view of the lens will be circular, and at the center, you know that every circle has a center. So at the center part, you are having optical center. So in short, this optical center is a geometrical center. Okay, this optical center is basically a geometrical center of this lens, and it's a very important point. Okay, and it's a very important point for lens. Okay, now, so once we have understood the optical center, there is a line which passes through, I would say imaginary line, I would say there is an imaginary line that forms kind of base for all the image formation. I have to make it a little more on top. This imaginary line kind of forms a base, right? It looks like a base for all the image formation. So that image formation has to take on some base, right? So if you require some base, something, you should have some ground like, right? If you want to stand somewhere, you require a ground, you require a base. Same way, to understand the image formation, I need to have a base or a line from where I can take or measure and do anything, right? So now, as you can see, I have that base ready here, and it's called principal axis. It's called as the principal axis. Let me write down the name, principal axis. Now, it is must that a principal axis should pass through the optic center. Okay, the principal axis is a line which passes through the optical center. Point number 2, the next thing which is required in a lens. Okay, so now when I'm passing straight beam of light, that means a parallel beam of light, let's consider that I'm sending a parallel beam of light. Okay, I'm sending a parallel beam of light on the lens. So when parallel beam of light is sent on the lens, you must have understood in the mirror, when I'm sending a parallel beam of light on a concave mirror, it focuses at the point called focus. So same way, we have a point for every lens which is known as focus, and it is a point where all the parallel lines, parallel to whom? Parallel to principal axis. All the light rays that are coming parallel to principal axis are going to pass through the focus. No doubt about that. They are going to pass through the focus, and I would call it F1. Now you might be thinking, why am I giving F1? There is a reason, because there is a focus that side also, which is known as F2. Why F2? Because light is coming from this direction for you. It's not mandatory that it has to come to this direction, it can come to this direction also. If light comes from this direction, then it will be focusing on F2. So you look here, mirror is only one-sided, the other side of the mirror is painted, coated, so light cannot pass through. So you only have one focus in one side, but lenses are double-sided. So when they have double-sided, you need to have the point on both the side of the lens. One is F1, focus this side is F1, focus this side is F2, and there is one more important point which is called 2F1. 2F1 is a point which is twice the distance of F1. Okay, this is the distance between optical center and F1, and 2F1 is twice the distance. Same way, here you have 2F2 also. See, it can change. If you take this as F1, this will be F2, or if you take this as F2, this will be F1. So it depends. It's not mandatory. There is no hard and fast rule saying that this should be F1, that should be F2. No, there is no hard and fast rule for that. Right? You can take one as F1, you can take other as F2. Right. Now I have these points. So now I'll remove all the lines because I don't want to delete my rays. So now I have F1 here. So I will now deal with only one side, and that is F2 here. 2F2. Sorry, 2F1. I have F1 here. I have F2 F1 here. Now, as I told you, if you have to understand the image formation, you need to understand the ray formation first. Okay. If you have to understand the image formation, what is an image? Image is a point where two rays intersect, right? Yes or no? Image is formed where two rays intersect. So first of all, if I want image, I should know how rays are traveling, isn't it? I should know how rays are traveling first. Then I will know what is my image formation, then different rule and then different points of image formation. So if I understand the rays, the rule of rays, then I will be able to easily do my image formation. So let us look into the rules of rays. Rule number 1, when a ray is coming parallel to principal axis, like this. When a light ray is coming parallel to principal axis, obviously you know that it has to pass through focus. Very straightforward rule this is. Okay. If a light is coming parallel to principal axis, after the refraction, see, you technically know that it is refraction that is happening in the lens. Why? Because glass is refracting the light. Now you already should be knowing what is refraction. Okay. Now it is because of refraction that the light is bending towards the focus and going through the focus. That is the first rule. That is my first rule. Understood? Second rule, rule number 2, is that if the light is going through the optic center, it does not get deviated, rather it passes straight and goes. Okay, it says that light does not get deviated if it is going through the optic center. And you should remember, principal axis is also a type of ray. I'm again saying it's not a ray, it is also something that is going through optic center. That's why it doesn't seem to bend. Understood? So the rule number 2 says that any ray that is passing through optic center, after the it will not get refracted, it will just pass straight. It will not get refracted, it will just pass straight. That is rule number 3. And rule number 4, now I told you there is a presence of F2. F2 is there. Rule number 2, if the light is coming through focus, now when I am saying focus, that means it is this side focus, side from where the light comes. Okay, the side from where the light comes, that focus I am talking about. When light goes through focus, I will draw with black color. If the light passes through focus, after refraction from the lens, goes parallel to the principal axis. After refraction, goes parallel through the principal axis. Right? Now, these are the 3 rules of ray diagram. Understood? These are the 3 rules of ray diagram. So what you have understood now? Rules of ray diagram. Okay. Now these rules of ray diagram can be extended to image formation. Okay, can be extended to image formation. Okay, can be extended to image formation, and let us see how it exactly happens. I will show you one point. Okay, I'm going to show you exactly one point and how that one point is going to form image for me. All right, now I will just turn this into like this. Okay, and I will take a new page. I have my principal axis. Now I am not showing lens as a whole, I'm just showing lens as a straight line. Okay, so understand that this is my lens. Okay, I'm not showing the whole curved part and all, I'm just showing that this is my lens. Now equidistance. Now the distance is very important. That's the reason why I have made the graph. Now let's consider that the f1 is somewhere 1 2 3 4 5 6 7 8 9. Oh, let's make it 7. 1 2 3 4 5 6 7. This is my f1. Oh, okay, 1 second, the pen has to be changed. Let me count again. 1 2 3 4 5 6 7. Here is my f1, and f2 has to be here backwards with 7. 1 2 3 4 5 6 7. It's my f2. So 2f is going to be double the distance. 1 2 3 4 5 6 7. This is my 2f2, and sorry, 2f1, sorry, this is my behind. 1 2 3 4 5 6 7. This is my 2f2. Okay, I have made the points. Lens I am just showing with the help of the straight line. Now I will show you one point. Let's take the point number 2, beyond f2 f1. Okay, beyond 2 f1. So let's consider that my object is beyond 2 f1. Now look here, this is my point. Okay, I am taking the object which is exactly beyond 2f. Now all my distances are proper, you see. f1 which is at the distance of 7 blocks, f2 at the distance of 14 blocks, 7 14, and f2 this side is 7 and 14. So my distances are same. My f1 is ready, my 2f1 is ready, my 2f2 is also ready. Now where is my object? Here is my object, and now I am going to form the ray diagram using 3 rules. I'm going to form the ray diagram using 3 rules. Now look carefully. Let's begin with the first ray, a ray that is going parallel. After the refraction goes through focus. After refraction goes through focus. Yes, this is how it looks like. A ray going through the principal axis goes undeviated. My second line is also ready. Third one, a ray that is going through the focus, after refraction goes parallel. Now you clearly see here, I have my 3 rays. Ray number 1, ray number 2, and ray number 3. Look here, I have made the lens into a yellow line because I don't want to draw the whole lens. So I'm just showing the plane of the lens here. Now where is my image getting formed? You see that my image is actually forming at this point. My image is forming exactly at this point. Now look at the properties of image that is being formed when it is beyond 2f. It is inverted? Yes. It is real? Yes. Is it diminished? You see here, this is 4 units, isn't it? What is the height? Approximately 4 here. The height is approximately 4 blocks. And the height here is 3 blocks. So it is diminished, inverted, and real. So this is the result of image formed by an object which is beyond 2f, which is exactly what we have. And where is the image position of the image formed? You look here. Where did the position of my image form? My image has formed between F1 and 2F1. Yes, it has formed between F1, here it is F2 is given by F2 because they have just exchanged the place. So it is between F2 and 2F2, right? And it's diminished. Yes, it is diminished because it is smaller, real and inverted. Okay. So as I told you, it doesn't matter. F1 can be here, F2 can be here, it doesn't matter. You just have to understand that what is the ray formation that you are going to do for this case. Right. So I hope you have understood this ray formation using a lens. Now, knowing the ray formation is not enough. Rather, you should be knowing sign convention too, because sign convention is going to help you to do problems here. Sign convention is going to help you to do more and more problems and make you understand how to use a proper sign to get an appropriate image and to get an appropriate magnification. So sign convention is for the next class, and if you wish that I take sign convention in the next class for 10th grade, please do tell in the poll that if you want me to take sign convention, and so that would be very, very helpful for me. So that is going to be helpful, and we will be seeing the next session. So it's all about that you tell me what to take next session. You tell me what should I be taking in the next session, which is going to help me to plan for a better class, right? Because again, I'm telling you, this whole show of Physics Revolution is only for you to understand the physics in a better way, because here I'm going to make the concepts of physics boil down to its essence, and that's my idea here, and that's what I would be looking for. So with that, I'll end my session now. We will see in the next session. Adios.